guys to go. Okay, so we've done sections 1, 2, and 3. We're going into 4 today. Lots of important things here. Lots of important terminology. So let's get started. Okay, it is warm in here today, right? Okay, all right. So we kind of started talking about this terminology last year, right? So we say that a function is increasing on an interval if, now visually we can see if something is increasing, but if I have 2 points, x values, right? And if x2 is greater than x1, okay? So if I have 2 points, x2 greater than x1, then f of x2 has to be greater than f of x1. That means that the function is increasing on that interval, right? So if on an interval, for each set of 2 points, f of x2 is bigger than f of x1, then it's increasing. Similarly, if on an interval, we say that a function is decreasing when for any 2 points, x1 and x2, and of course x2 has to be bigger, then f of x2 is smaller, then we say the function is decreasing on that interval, right? So no matter what 2 points I pick. So that's how we say if something is increasing or decreasing. Similarly, a function is constant on an interval if for any 2 values, x1 and x2, f of x1 and f of x2 are the same. Okay, that's when the function is increasing. And I know you know when you look at a graph if it's increasing or decreasing. Remember, we always read graphs left to right. I know you know how it looks like, how it looks, but mathematically that's how the statement goes. So, okay. We're going to consider the following graph and determine the intervals on which the function is increasing, decreasing, or constant. So, just by looking at this, I know that this function is increasing here. It stops increasing right there, and then it's decreasing. It's increasing again, and then it's constant. So here it stops decreasing at this point, and then it increases until there, and then it's constant. So when we want to determine the intervals on which the function is increasing or decreasing, the intervals are the x values of the intervals, all right? The x values. So here's how we do this. So where is the function increasing? The function is increasing from negative infinity to x equals -3. Now, it's got to be an open parenthesis. Why? Because you can never say at 3 is something increasing or decreasing. Something increases on an interval. It has to increase from somewhere to somewhere. So it could be increasing from -3 to 3, and then like from negative infinity to -3, and then decrease from -3 onwards, okay? We do not include it. So where else is it increasing? From 2 to 6. So union, 2 to 6. It's decreasing from -3 to 2. And then it's constant from 6 to infinity. So remember, always open parentheses, regardless of, you have an open circle or not. Okay? All right.
What if it's,
Yeah, go. Are you sure? Oh, because I was just going to ask if there were questions. Betty? Yeah.
So if we're in the terms of increasing, decreasing, and constant functions, we never use brackets.
Mm-hmm.
So even if 2, like where 2 is, where it would start increasing again, even if it was a filled circle, it would still be.
What about, does it dotted lines, is that that?
No, the dotted lines, I just did it for you guys. After this, I'm not gonna do that again.
Like, what are those things?
These? You mean the y values? The y values don't mean a thing in this, okay? Okay, so here we go. Use the graph to the nearest 0.5 unit and to say on which interval something is increasing or decreasing. So here, this function is always increasing, right? So I say it's increasing from negative infinity to infinity. This function is increasing from where to where? From 2 to infinity, and it's decreasing negative infinity to 2. Remember, like that order matters, right? You can't say 2 to negative infinity. Okay, here it's increasing negative infinity to 0 and union 3 to infinity. It's not decreasing anywhere, and it's constant.
At 6 to 4.
Nope.
0 to 4.
0 to 4. Very common mistake. Students go to the y value. 0 to 3. It's very, very common. Students go to the y value, right? Eventually, your eyes will be trained. It won't be an issue starting next year, but this year, always like, watch out. Yeah.
Oh, wait, do you have to write the first noun for decreasing or write that?
That's what I was.
See, it's like if you just don't say that.
Yeah, I guess, yeah, you don't have to say. Okay, so, but, if on my test, if I have given you like increase, decrease, none, if I've said them, then write none next to decrease. Do you see what I mean? Okay, so here, increase from negative infinity to negative 1, and 1 to infinity, and then it decreases in between negative 1 to 1. Now, let's stay on this page for a minute because I need to say something. So here, this was increasing, and then it began to decrease. The point where the graph switches from increasing to decreasing, we have a maximum. And then here, this thing was decreasing, and it switched to increasing. The point where a graph changes from decreasing to increasing, we have a minimum, okay? Now, that is exactly what this says. The umbrella word for minimum and maximum is extrema, or one extremum, 2 or more extrema, okay? One minimum, 2 or more minima, okay? So, we're going to talk about a relative extremum, and relative minimum and maximum, and then absolute minimum and maximum. A relative minimum and maximum is basically any point. Let's talk about maximum. A relative max is any point where the graph switches from increasing to decreasing. Okay? So this is a maximum. This is another maximum. If one of those maxima also happen to be the very, very highest point that the graph ever reaches in its entire lifetime, it's also called an absolute maximum. Okay? It's an absolute maximum. All right? Same thing with a minimum. Wherever the graph changes from decreasing to increasing, it's a minimum. But if a minimum happens to be the very lowest point the graph reaches in its lifetime, it's an absolute minimum. Okay? Now, often in calculus, we're usually never talking about the graph in its entire lifetime. We're usually just talking about a very specific interval. And then so it's very easy. If something is the highest point, it's the absolute maximum. If it's one of the maxima, not the absolute, we call it a relative maximum. Okay? Okay. So, some important things here. When we say location of the maximum, or the minimum, we're talking about the x value, okay? So let me write that here. Location is the x value or x coordinate. Value is the y coordinate. Okay? Classify, estimate, and classify the local and absolute extrema on this graph. Okay? Classify means say if it's like min, max, absolute, or not. Okay? So we definitely have a maximum here. So I can say there is a relative maximum at 0, 3. Okay? Now, there is another notation. You can also say there is a relative maximum at f of 0 equals 3. This second one is called function notation. Before you ask me which one do we need to know, I really would like you guys to be comfortable with both versions of these. And on the quiz or test or whatever, sometimes I will ask you to put it in function notation. And then if I don't ask you, it's up to you. Okay? So now, these two are absolute minima, right? So there is absolute minima and one of them is f of -1 equals -1. And f of 1 equals -1. You don't have to.
Oh wait, so there can be two absolute.
Minima? Yes, yes.
So, but they can't.
Because they're both like they're like co-chairs.
Could there be more than two?
Yeah. There's no law.
There can be infinite.
There's no law. Okay. Hang on. Give me an example of a function that could have infinite absolute maxima.
Oh, cosine or sine.
Cosine or sine, right? There's one every pi. Okay. Run. Okay. So. Huh? Okay. So take a look. This one we can just do by looking at it, right? There is an absolute minimum where? F of -3 equals -4. Now, you guys remember how to find minima and maxima, right? On the calculator? Yeah. Okay, so for this one, by the way, the location of the minimum is x equals -3. The value, the minimum value is y equals -4. Okay, so the minimum value of this function is -4, and it happens at x equals -3. Do I need to go over on the calculator how to find? No. Okay, I'll just tell you. Yeah.
For the answer, you have to write location and min value.
No, I'm teaching you what that terminology means, what location means, because sometimes you're asked for the location, sometimes you're asked for the value. If I just say find the minima, you can just say there is an absolute minimum at f of -3. Okay?
So if it says classify the extrema, then that's
Right.
the answer.
This is the answer. This.
For this one, is there any there's no absolute maximum?
Correct. There is not. So here, what is this, by the way? Let's just say that. What is that? What kind of max? Relative max. What about this one? Relative max. What about this one and this one? Both are relative minima, okay? Because look, the graph goes far below, so there is no absolute here. Okay. Yep. So this one here, you guys we've been doing these for years now. I'm just gonna go on to this word problem because that's more exciting. Okay? All right. Oh, wow.
Wait, it's just two. You don't do a union, right?
No union. Union is only for intervals.
Sorry.
Sorry.
Yep.
That number, how would we just plug that calculator?
For which one?
Number, the one you skipped.
3a. Yeah, what you would do is you would plug f of x into the graph and find, like, analyze graph, max or min.
Yeah.
Yeah, okay? We're actually going to do that with this example number 4. So,
This is a better one too.
yeah, word problems are always better. We know this. Yali, go. Let's take out calculators, by the way.
Wait, for B, I don't understand why, like, the higher, like, the maximum, like, no? Why is that not the...
Okay, is that the highest point that the graph ever reaches in its entire lifetime? Or does the graph go up higher to the left, to the right?
So if it didn't go up higher, then it would have been...
Right,
absolute amount?
right. Okay? All right. So here. Oh, what happened? All right. Why did this thing freeze? So this, in this problem, this is the function for miles per tank of gas, where x is the speed of the car in miles per hour. So, depending on what speed you're going, f of x tells you basically like the MPG, but the miles per tank, okay? So you could imagine if you're driving really, really fast, you're not going to get that many miles per tank. But if you're not driving, if you're driving, okay, right. So what speed, here's the question, what speed optimizes the distance can travel on the tank of gas? So what speed should you be driving so you can get the most miles out of that one tank? Hang on. So here's what we're going to do. We're going to graph this. I know you guys know how to find the answer to this, but as always, it's always like the process that I want to find, okay? So let's go ahead and graph this one. So this is going to be negative point, how many zeros? 1. X squared plus 3.5x plus 240. Enter. Okay, I don't see a thing. Okay? Okay. So, let's do this for a minute. Okay, so this is x and f of x. What does x represent in this problem? The speed of the car, right? The speed of the car. So, okay, what is f of x? The distance what? That it can go on one tank of gas, right? So that this is the distance per tank of gas. So now, the reason why I'm doing this is, I don't want you to just mindlessly zoom out, right? Because that's not understanding the problem. What I want you to do is, I want you to go to Menu. Number 4 is Window Zoom, Window Settings. For your X min, because this is the speed of the car, we're going to go from 0 to, what's a reasonable speed for the car? Okay, let's go a little bit more.
100 miles an hour.
Okay, 100 miles an hour. You know what? Let's splurge 120. Nobody drive 120, but I just want like a good range, okay? So tab. Okay, Y, that's the distance per tank of gas. So we are told that we are given a number to go on, 360, okay? So, it's around there. So again, I'm going to go to like 400, right? Give or take, right? And now look, I get exactly what I'm looking for, okay? So what I need to find here is the maximum. Yeah.
Why do you say like you still go somewhere if you're going 0 miles an hour?
Huh?
Like it says that you go 240 miles per tank at 0 miles an hour. Like when the X is 0.
Oh. At 0 miles an hour? Maybe if you're like driving like close to 0? I don't know. That's a good question. Okay, but that doesn't even like sound very reasonable because you're not, if you get out and push. Okay, so the maximum is 70, 362.5. Okay, so this is the speed. This is the maximum distance. Okay, so now the question is asking what speed optimizes the distance the car can travel, and then how far is that optimum speed? So you can say in words, the car will travel a maximum distance of 362.5 miles at the speed of 70 miles an hour, right? So by that, if you're going too fast, then you're not going to be going too far. And if you're going too slow, then you're just like kind of overworking the car in a different way. And so maybe that's what it could be like. If you're just going at like 1 mile an hour, you're going to be wasting just energy, right? So you could only go like that much. Okay? Any questions on this? So again, listen. We learned how to find this last year, right? My point is not to find this. This year, it's to formulate an English sentence coherently. And it's also, given just a random problem, being able to fix the windows without just mindlessly zooming out. You need to be able to come up with a reasonable domain and range for your problem. Okay, average rate of change. Okay, let me say a few things about average rate of change. Somehow, students always get the average rate of change problems on the test wrong. Let me tell you why that happens. Because they find it so easy that when it comes time for the test, they're like, oh my God, that's easy. They don't go over it. And then, right? I know each one of us is guilty of that at some point. And then now you're in the middle and you're like, oh my God, I totally knew how to do this, but now I forgot. I really should have reviewed. There is no reason why any of you guys should get any of this wrong. But let's listen to this for a minute. Okay, average rate of change. Okay. Your speed is how fast you're going, right? It's the rate of change of your position. It's how fast your position is changing, how fast you're going from A to B. So suppose you travel 300 miles and it takes you 5 hours. What's your average speed? 60. Were you going 60 every single time? No. But your average, beginning to end, was 60. So that's average rate of change. If I have, look at this for a minute. If I have a function, look at the y value. It's here, and then the y value is here, and it goes up a little bit, and then it goes back down, and it goes back down, and it goes back down. In between this point and this point, the y value goes up, and it goes down. If I connect those points with a line, it will be called a secant line because it crosses the graph at 2 points versus a tangent line. Remember secants in geometry? Now, if I find the slope of that, that will be the average of all of these y values here. Okay? So, how do you do this? Literally by slope. Okay? So, the rate of change here is slope. And we know slope to be this. But what's y now? F of x. So that's f of x2 minus f of x1 over x2 minus x1. Do you see how this is exactly the slope formula from before? Yep. Okay. So let's find average rate of change here. This is an interval, -3 to -1. So this is x1, this is x2. F of x2, I plug it in to the right, and it's 0. So that's f of, what is it, -1. And then f of x1 is f of -3. It's -24. Okay, f of -1. Take -1, plug it into this function, you get 0. F of -3, you get -24. Okay, so average rate of change. This is the slope of the secant line, average rate of change. This is f of -1 minus f of -3, -1 plus 3. So 0 plus 24 over 2, 12. Okay? So here, the interval is 2 to 4. So the slope of the secant line is going to be f of what? 4. The second one first. Final minus initial. Minus f of over 4 minus 2. So f of 4, just look on the graph. What is it? -2. Minus, what's f of 2? 2. All over, that's a lot of 2's. It's -2. Okay? All right. Too many 2's. Okay, so that's that.